Hey everyone, and welcome to today's explainer. Now, I am really thrilled to dive into a topic today that might seem, well, highly specific at first glance, but it's actually one of the absolute most powerful hidden budget levers in modern industrial engineering. We are talking about cable trays, specifically, how to choose the precise ladder cable tray for massive industrial projects. If you have ever wondered how proper, strategic cable management directly impacts the bottom line of a multi-million-dollar facility, you are in the perfect place. So, let's get right into it.
680,000 yuan. Nope, that is not a rounding error, and it's definitely not a minor budget adjustment. That is the massive material savings achieved on a recent 4.2-kilometer Shandong petrochemical project. And how exactly did they pull that off? Well, they didn't cut corners on safety, and they didn't compromise the electrical grid either. They literally just evaluated their materials and switched their specification from standard solid bottom trays to ladder-style trays. It's really that simple.
So what's the secret sauce behind those massive savings? It all comes down to airflow. You see, a solid bottom tray kind of just traps heat, but ladder trays with their open rungs dramatically increase airflow. Because the cables were exposed to ambient air and running cooler, it reduced the derating factor by 12% on average, and cooler cables conduct electricity a whole lot more efficiently. In fact, this 12% reduction in heat-related derating allowed the engineers to specify exactly one conductor size smaller on 38% of all their power cable runs. Smaller cables mean significantly less copper, which translates directly into massive cost savings, and they did it without sacrificing an ounce of performance.
To ensure you can leverage these exact same principles in your own designs, here is our roadmap for the explainer today. 1. The Shandong Project, high stakes. 2. IEC load ratings explained. 3. Mastering the 40% fill rule. 4. Materials, coatings, and life cycles. And finally 5. Cinema standard cable management.
Section 1. The Shandong Project, high stakes.
Section 2. IEC load ratings explained. Okay, let's dive into this. We just saw the massive upside of proper tray selection, but there is also a severe downside if your specifications aren't perfectly aligned with reality. To get those specs right, knowing exactly how much weight a tray can hold is, well, it's non-negotiable. We use the global standard IEC 61537 to measure this. The load ratings map strictly from Class A, which holds 50 kilograms per meter for your light loads, stepping up all the way to Class D, which is engineered to take on 200 kilograms per meter for extra heavy loads. You simply cannot guess here. You absolutely have to match the class exactly to your actual installation conditions, making sure you account for every single heavy power cable that will rest on those rungs.
So why am I emphasizing this so strongly? 380,000 yuan. That's why. On that exact same Shandong project we were just talking about, one specific section was undersized by just a single load class. Just one class down. It's almost hard to believe, but that single error resulted in a punishing 380,000 yuan in rework costs. The tray system literally couldn't support the physical weight of the electrical lines, meaning the entire installation had to be pulled out, scrapped, and totally replaced. It is a stark reminder for all of us that precision pays off, and guessing costs dearly.
Section 3. Mastering the 40% fill rule.
While load capacity is strictly about weight, tray width is all about physical space. You're going to constantly hear industry veterans talk about the 40% fill rule. What that actually means is your cables should only ever occupy 40% of the physical cross-sectional area of your ladder tray. But why? Well, the remaining 60% isn't wasted space at all. It's absolutely essential cooling headroom. Like we learned with that 12% derating drop earlier, cables desperately need room to breathe to operate efficiently. Think of it like leaving enough space in an oven for the hot air to actually circulate. Furthermore, this 60% gap provides critical future capacity. If your facility expands or upgrades technology 5 years down the line, you have the headroom ready to go. Maxing out your tray space on day one is a guaranteed recipe for overheating systems and some incredibly expensive structural retrofits later on.
Section 4. Materials, coatings, and life cycles.
Now that we've tackled weight and volume, we have to look at the physical environment. Environmental challenges completely dictate material selection, and they directly impact your project's overall lifespan. Let's compare the 4 key materials you'll usually be choosing from. Hot-dip galvanized, or HDG steel, is your absolute workhorse for standard industrial applications. But if weight is a big constraint, aluminum 6063 T5 offers a really great lightweight alternative that still maintains high corrosion resistance. Now, if you're dealing with severe corrosive zones, think harsh chemical plants or extreme salt spray, stainless 316L provides unmatched high durability. Finally, there's FRP, or fiberglass reinforced plastic, which is perfect for non-metallic needs where high chemical resistance is a must. Engineers have to specify these materials based strictly on local corrosion zone thresholds and lifecycle cost data. It's all about picking the exact right tool for your specific environment.
Let's look at a real-world application of this logic. A recent coastal project in Jushan offers a perfect example of how a really smart, very specific coating choice delivers immense return on investment. Coastal environments are absolutely brutal on steel because of the relentless salt spray in the air. Instead of just going with a basic, out-of-the-box coating, the engineering team specifically required HDG trays with a very robust 65 micrometer hot-dip galvanized zinc coating. That 65 micrometer layer builds a completely different life cycle. A standard tray in that harsh coastal environment has an expected service life of a mere 7 years before corrosion compromises the structural integrity and forces a complete expensive replacement. But by specifying that one robust layer of hot-dip galvanized zinc, the installation's service life was extended to an impressive 22 years. They more than tripled the lifespan of the infrastructure with just one single specification tweak.
And what's the bottom line here? That simple, strategic coating decision cut the 20-year material costs for the facility by 40%. By spending just slightly more upfront for a thicker zinc coating, they completely avoided the insane costs of ripping out and replacing the entire system twice over 2 decades. It's a fantastic reminder that when we choose cable trays, we aren't just buying shaped metal, you guys. We are buying time.
Section 5. ZIMA Standard Cable Management. To execute these long-term strategies effectively, you really need a manufacturing partner that consistently meets these rigorous global standards we've just outlined. Take Sinma, formerly known as Shanghai Sinma Busway and Cable Tray Co., Ltd. They are a highly reliable manufacturer of intelligent cable management solutions. They produce comprehensive cable tray systems, busways, and seismic bracing designed specifically for highly critical infrastructure. Things like modern data centers, rail transit systems, commercial buildings, and heavy industrial plants.
What makes their approach highly relevant to everything we've explored today is their authoritative compliance. ZINMA's products comply with all the crucial global specifications required for serious engineering. They meet IEC 61537 for those exact load classes we just discussed, alongside NEMA VE1, BSEN 50085, and GB 3125 standards. When your tray manufacturer hits every single one of these independent verification marks, it guarantees the safety, the operational efficiency, and the lifecycle longevity that project managers depend on to keep their budgets intact.
So, as we wrap up today's explainer, I want to leave you with this final, somewhat provocative thought. Think about the infrastructure you or your team are planning right now. Based on everything we've looked at today, from ladder tray airflow and IEC load classes to mastering those fill rules and material life cycles, is your current cable tray specification costing you a 40% future premium? Understanding the vital details hidden in your engineering specifications really does make all the difference in the world. Thanks so much for joining me to break this down today. Keep learning, and I'll catch you in the next explainer.